If two lines are parallel, they have the same gradient. They're going in the same direction. So if we had a line with the equation y equals 2x plus 5, it's in the form y equals mx plus c. It's got a gradient of 2 and a y-intercept of 5. So for every one it goes across, it goes up 2. Any other line with the gradient of 2, so y equals 2x minus 1, is parallel. They're going in the same direction. So if two lines have got the same gradient, they are parallel. This question says find the gradient of a line parallel to 2x minus 5y minus 4 equals 0. So this is not in the form y equals mx plus c, and we can find the gradient by putting it in that form. So we need to make y the subject. So I will plus 5y to both sides. 2x minus 4 equals 5y. I want y by itself. I need to divide every term by 5. So 2/5 x minus 4/5 equals y. Or writing it the other way around, y equals 2/5 x minus 4/5. So now it's in the form y equals mx plus c. We can see the gradient is 2/5. M is 2/5. So the gradient of a line parallel to this line will have a gradient of 2/5. One for you to try. So pause the video and give it a go. Find the gradient of a line parallel to 3x plus 2y plus 5 equals 0. Let's make y the subject. So take 3x away from both sides and take 5 away from both sides. We want y by itself, so let's divide every term by 2. So now it's in the form y equals mx plus c. Any line parallel will have the same gradient, which is negative 3/2. Find the equation of the line parallel to 5x minus 2y minus 11 equals 0 that passes through 0, negative 4. So 0, negative 4, that would be its y-intercept. So we need to find the gradient of the original line, then the parallel line will have the same gradient. So make y the subject, plus 2y to both sides. 5x minus 11 equals 2y. Half everything. 5 over 2x minus 11 over 2 equals y. So the gradient is 5 over 2, 2.5. So now the gradient is 5 over 2. For our new line, the y-intercept is at negative 4. It goes through 0, negative 4. That means the y-intercept is negative 4. So the equation of the line is y equals 5 over 2x minus 4. One for you to try. Give it a go. So make y the subject, put it in the form y equals mx plus c. So just plus y to both sides, and we get y equals 3x plus 7. So the gradient is 3. M equals 3. It goes through 0, 5. That is the y-intercept, where when x is 0 is the y-intercept. So the y-intercept's 5. So y is equal to 3x plus 5. So perpendicular gradients. If two lines are perpendicular, that means they cross at a 90-degree angle. So let's say these two lines are perpendicular. They cross at a 90-degree angle. If this line, the negative one, has a gradient of negative 2, this one, positive 1, will have a gradient of a half. If we had two lines that were steeper, and say we had a gradient of -3, the perpendicular line will have a gradient of 1/3. So these are always kind of the opposites. So if one gradient is 3/2, the perpendicular gradient will be flipped and minus, negative reciprocal, a negative and a flip. If one gradient was 4, the perpendicular gradient will be negative reciprocal, the negative reciprocal minus 1/4. If one gradient was 1/3, the other one would be negative reciprocal -3. So perpendicular gradients are always a negative reciprocal, and we can also say they multiply. So perpendicular gradients m1 times m2 always equal -1. So they always multiply together. Two perpendicular gradients multiply together to make -1. So one is a negative reciprocal of the other one, and they multiply together to give -1. So write down the gradient of the line perpendicular to y equals 2x plus 5. It's got a gradient of 2. We want the negative reciprocal, so it's going to be negative. The reciprocal of 2 is 1/2, flipped over. The second one, it's got a gradient of -4, so its perpendicular gradient is going to be positive, and it's the reciprocal of 4, 1/4. The third one, we've got a gradient of 1/3, so it's going to be negative, the reciprocal of 1/3, 3. For D, we've got 2/5, -2/5, so it's going to be positive, and the reciprocal of 2/5 is 5/2, flipped over. And the last one, we've got a gradient of 1, so it's going to be negative, and the reciprocal of 1 is 1. 1 times -1 is -1. Okay, 5 for you to try. Give them a go. So we should have 1/5, 7/2, minus 5/4, 1, and minus 1/6. Find the equation of the line perpendicular to 3x minus 4y plus 5 equals 0 that passes through 0, -2. So we need to find the gradient by making y the subject, putting it in the form y equals mx plus c. And then we'll do the negative reciprocal of that gradient. So plus 4y to both sides. And then divide every term by 4. So the gradient is 3/4. So the perpendicular gradient is a negative reciprocal of 3/4 minus 4/3. It's got a y-intercept of -2. That's when x equals 0. So we have y equals minus 4/3 x minus 2. One for you to try. Give it a go. Let's find the gradient of 2x plus 3y minus 4 equals 0. So make y the subject, take away 2x from both sides, add 4 to both sides, and divide every term by 3. So we've got a gradient of minus 2/3. That means the perpendicular gradient is going to be positive, and the reciprocal of 2/3, which is 3/2. The y-intercept is 9. That's been given to us. So the equation is y equals 3/2x plus 9. Find the equation of the line perpendicular to 5x minus y minus 3 equals 0 that passes through 2, -5. So this time we've not been given the y-intercept. We're going to have to work that out. So let's make y the subject, plus y to both sides. 5x minus 3 equals y. The gradient is 5 for the original line. So the perpendicular gradient will be the negative reciprocal. The reciprocal of 5 is 1/5. So we've got the gradient and we've got a point. And we can use our formula. So the gradient times x minus x1 equals y minus y1. So we've got x1, y1, and the gradient. Let's just substitute them in. So minus 1/5 equals x minus 2. No, minus 1/5 times x minus 2 equals y minus 5, so plus 5. So that's the equation of a line. I'll put it in the form ax plus by plus c equals 0. So times by 5, times both sides by 5. Expand the bracket. And then make it equal to 0. So we've got x plus 5y plus 23 equals 0. One for you to try. Pause the video and give it a go. So again, find the equation of the line perpendicular that passes through a point. So make y the subject, find the gradient of the original line. So take away x and add 7 to both sides. Divide each term by 4. So we've got an original gradient of minus 1/4. That means the perpendicular gradient is a negative reciprocal, which is 4. And we've got x1 and y1. So the gradient times x minus x1 equals y minus y1. It's like the change in y over the change in x rearranged. So that is 4 times x minus 5, so x plus 5, equals y minus 2. Expand the brackets, so 4x plus 20 equals y minus 2. Make it equal to 0. I'm going to keep the x positive, so take away y from both sides and add 2 to both sides. So that's 4x minus y plus 22 equals 0. We've got L1 passing through 2 points, L2 passing through 2 points, and we need to show they're perpendicular. So if we work out the gradients of both of them, we can show they're perpendicular by showing one's a negative reciprocal of the other one, or that they multiply to make -1. So for the first one, we've got x1, y1, x2, y2. So that's the gradient of the first line is the change in the y's, y2 minus y1 over x2 minus x1. So -2 plus 5 is 3. 3 plus 1 is 4. The gradient for the first line is 3/4. Second one, we do x1, y1, x2, y2 again. So the second gradient is the change in the y's, y2 minus y1 over x2 minus x1. So that's 1 take away 9, -8 over 2 plus 4, which is 6. And we can simplify that to -4/3. So we can see that they're the negative reciprocal. And just to show it, we can say 3/4 times -4/3 is equal to -1. Therefore, perpendicular. One for you to try. pause the video and give it a go. So the first line, L1, we work out the gradient. So the change in y, y2 minus y1, over the change in x, x2 minus x1. And the second one, the change in y, 6 minus 1, over the change in x, 5 minus 3. So the first one, we've got negative 2/5. And for the second one, 5 over 2. And negative 2/5 times 5 over 2 is negative 1. Therefore, they are perpendicular. One is the negative reciprocal of the other one. They are perpendicular lines.